In this session, we are going to talk about capacitor. Any system which can store charge is called capacitor. First, I will start with the simplest capacitor, which is spherical capacitor. Let's assume we have one sphere with positive Q charge. So you have a positive charge at the surface of the sphere. This one, and you need to assume there's another charge, another sphere with negative charge, identical sphere with negative charge, and the distance between these two spheres is infinite. Distance between these two spheres is infinite. Okay. The radius of the sphere is r. What is the potential at the surface? What is the potential at the surface of positive charge sphere? V plus will be equal to Q by 4 pi epsilon naught r. What is the potential between the negative charge sphere? Minus Q by 4 pi epsilon naught r. The potential difference between the surface of these two spheres will be V, and which will be equal to V plus minus V minus. This you will get Q and minus Q minus, so it will be 2Q, and you have a common in denominator, 2 pi epsilon naught r. This will be V. Now you calculate Q. Q will be 2 pi epsilon naught r. Now in general, epsilon naught rv, in general 2 pi epsilon naught is constant, which is Cv. Q is equal to Cv. So what will be the value of C? Value of C, 2 pi epsilon naught r. This is your capacitor. Now we'll take another system where two spheres are kept infinite distance. We have another two spheres. These two spheres. One is positively charged, another is negatively charged. The radius of this sphere is A, same as this. The distance between these two spheres is B. Electric field at this point, electric field at the point P due to sphere 1 and due to sphere 2. So at P due to sphere 1 is E1, and at P due to sphere 2 will be E2. So E1 will be equal to 1 by 4 pi epsilon naught Q by x square. X is the distance between center of a sphere and this point. The x is the distance between center of a sphere and this point P. Okay, and what about the electric field due to sphere number 2? That will be 4 pi epsilon naught Q by what will be the distance from the center of sphere to this point. Center of this sphere to this point is total distance b, and this one x, the b minus x up to this point. So here you will get b minus x square. B minus x square. Okay, the total electric field E will be equal to E1 plus E2. You take 1 by 4 pi epsilon naught common, you will get Q will also be common. You will get 1 by x square, and this minus 1 by b minus x square. Now you know this formula. Formula is like electric field at any point will be partial differentiation of V with respect to R. If you want to calculate the total V, you got to integrate it minus E dr. I'll apply the same formula. I'll apply the same formula over here. The potential between these two spheres will be equal to a to b minus a integration. This whole bunch of things, 1 by x square minus 1 by b minus x square into q by 4 pi epsilon naught into dx. Okay, then you calculate this. Q by 4 pi epsilon naught common, you integrate it 1 by x a to b minus a plus 1 by b minus x b minus x this is b minus x. Again same a to b minus a. When you calculate it, you will get V equal to 2q by 4 pi epsilon naught b minus 2a by a b minus a. Similarly, q will be equal to 2 pi epsilon naught a b minus a divided by b minus 2a into v, and we know q is equal to CV. That means you got C. The value of C will be nothing but 2 pi epsilon naught a b minus a divided by b minus 2a. This is the formula. Okay, in next session we will derive an expression for parallel spherical capacitance, actually parallel cylindrical capacitance. The capacity of a parallel spherical, not spherical, cylindrical capacitance.